So the 60 raised to the power 2, we have this. Then 70 raised to the power 2 is 4,900. This is 4,900. 4,900. Then 50 raised to the power 2 is 2,500. 2,500. Now, what else do we need, class? What else do we need? I think that's all right. So let us sum everything together. So this plus this, we have 300. This plus this, we have 260, right? Then this, we have 2,000 plus 200 plus 900 plus 4,800 plus 4,200, then plus 2,000 plus 200 plus 900 plus 48. We have 4,200 plus 3,000 class. Everything is 1,500. That is 15,100. And the x square will be 1,600 plus 100 plus 900 plus 3,600 plus 4,900 plus this. Then here will be 13,600. 13,600. Now, to apply this formula, right? So for beta 1, beta naught here. For beta naught here, we have summation x squared is equal to 13,600, right? Into y, and our y is 300, minus, right? Minus, n is the number of what? Okay, minus x, which is 260 into xy. That is 15,100, sorry. All over n is the number of observations, the number of candidates given to us, which is what? 6. 6 altogether. Abubakar, Pius, Adekunle, Bola, Ahmed, and Michael. That's 6. So we can see that 6 into x squared, which is 13,600, right? Minus, now, the summation of x, which is 260 squared, right? So we can say the beta naught cap will be, this time, this we have 13,600 times 300. Here will be 408000, right? We have this minus 260 times 15,100. 15,100 we have 3,926,000, right? So 6 times this, we have 6 times 13,600, right? Here we have 81,600 minus 81,600 minus 260 squared. Here we have 67,600, right? 67,600. Then we can rewrite this to be this minus this, we have, right, minus 3,926 we have 4080, right, minus 3,926. Here we have 154,000. Then this minus this, we have 81,600 minus 67,600. Here we have 14,000, right? Right. So you can say this divided by this. What do we have, class? 154 divided by 14 we have 11. So beta naught cap is 11. Beta naught cap is what? 11. So let's try to get the beta 1 now. So what is beta 1? Class, what is beta 1? So 11 is the beta naught cap. So what is beta naught, right? So I will have to clean this to have more space for beta 1. Now, using this formula, right? So we say n multiplied by xy. You remember, our n is the number of observation, which is 6. 6 times xy is 15,100. 15,100 minus xy, x summation y, which is what? 260, 300 all over class. If you notice something here, the general determinant for beta naught and beta 1 are the same, right? So there's no need for us to calculate that again. If you are very sure that what you calculated here is correct, class, you can use the same value here. It's the same thing. So, and here we have 14,000 all true, right? So we can say beta 1 cap will be this time, this we have 6 times that this will be 90,600 minus 260 times 300 class. We have 78,000 all over what? 14,000. Then the beta 1 cap will be 90,600 minus 78,000. Class, we have 12,600 all over 14,000, right? All over 14,000. Now, the beta 1 cap will be this divided by this, we have divided by, so class, this will be 0.9, 0.9. So we can rewrite this using, the model by saying that the percentage of fault here, will be VPI is equal to, beta naught is 11 plus 0.9 CH, right? Plus error term. Now, we've tried to feed the regression model plus error term. So this is use the above data to obtain the least square estimate of beta naught and beta 1. So the value for the estimate or the value for beta naught is 11, while the value for beta 1 is what? Is 0.9. Now, the second one, interpret the estimate. So how do we interpret our result? Class, how do we interpret our result? Now, to interpret the result, now, and you can also try the other formula, like I said, irrespective of the formula that you use, whether the actual or deviation formula, you are expected to get the same result. Maybe the next class we try, to use the deviation formula for the same question so that we see whether we are going to get the same result or not. Or you can also try it on your own, and if you have any other challenge, you can just put it on the comment so that I can do it and send to you personally, right? So, interpretation of the result. Now, using this model now to interpret, right? To use this model to interpret, now to interpret the beta naught cap. So the beta naught cap is, it is called the intercept coefficient. It is the intercept coefficient and shows the value of what? 11, 11 here. It shows the value of 11, which means that the value of percentage of fault will be 11 without considering or consider the hours of what? Campaign. So without consider the hours of campaign, the percentage of fault will be what? Will be 11. And it represents the beta naught, which is the slope, which is the what? The intercept coefficient. Is the intercept what? Coefficient. Now, why? So it shows the value of percentage of fault without considering, the what? The hours of campaign. Without consider hours of campaign. That means the percentage of faults that this candidate may have without consider the hours of campaign by each candidate will be what? 11. So it now depends, the examiner. This can be 1,000, it can be million, but we just have that value here, 11. So what is now the hours of campaign. Now, the beta 1 here, beta 1 cap, it is the slope coefficient, right? Is the slope coefficient and implies that a unit change in hours of campaign will bring about 0.9 increase in percentage of what? Of vote. Class, sometimes this 0.9 can be minus. If you have this to be minus, instead of increase, it will be what? Decrease, right? Let's assume this is minus now. Then the interpretation will be that we bring about a 0.9 decrease in percentage of vote. But because it's positive here, so a unit change in hours of campaign here by this candidate here will bring about a 0.9 increase in the percentage of what? Of vote. Right? And you can see, if we change this value to 1 to any value now, it is these hours of campaign that we change that will make the percentage of vote also what? To also change. To also change. So 0.9 here implies that a unit change in hours of campaign will bring about a 0.9 increase in the percentage of vote, class. In the percentage of vote. So it's very, very simple, class. It's very, very simple. And you can also try the other method and see whether you are going to get the same answer. But irrespective of the formula that you use for simple linear regression analysis, whether the actual formula or the deviation method given to you, we are expected to get the same answer. So the next class, by God's grace, we try to do a multiple regression analysis by prove what the multiple regression, how do we get the parameter for multiple regression analysis, and to also apply the figure like this and interpret our result. To also apply the figure like this and interpret our result. So I will advise you to subscribe to this channel for you to have access to those videos as we are trying to upload the subsequent video, right? And I hope you're enjoying today's class. Thank you.